Hello and welcome to the first unit of the AP Statistics curriculum. In each one of my video lessons, I will go through each unit of the AP Statistics curriculum. The way it is structured is that you will have the broad topics of the unit, followed by very broad vocabulary, followed by the in-depth detail. The first unit is exploring and understanding data. The topics covered in this unit are types of variables, displaying data, and understanding data. To start off with the vocabulary, we're going to start off with categorical or qualitative data, which are just variables that take on labels. For example, we could have back color as one of them and phone company. What I mean by categorical is that you can assign an adjective to them, which is very simply put. For example, phone company, we can talk about it being an Apple phone, a Samsung phone, a Sony phone, etc. And for back color, we can have, for example, red, green, blue, black, etc. Next, we're going to talk about quantitative data, which are just variables that have a measurable quantity. The most common ones that come up during the AP Statistics exam are weight and height. So for example, weight can be 20 kilos, 30 kilos, 40 kilos, etc. It's just something you can assign a value to. You'll see me interchangeably use categorical and qualitative because a lot of students misinterpret qualitative as quantitative due to this similar pronunciation. Just remember, categorical means qualitative. Next are going to be variable types. So the key ones that come up are independent variables and dependent variables, which are just your x and y axis variables. Independent variables are variables that create an effect in the dependent variable, which is your y-axis variable. And dependent variables are variables that depend on the independent for an effect. So for example, your independent variable could be weight, and your independent variable could be amount of food eaten, and your dependent variable could be weight. So what this means is that weight depends on the amount of food that you've eaten. Next, we're going to talk about types of graphs. The first one that comes up is bar charts, which is just using bars to display data. Now, the only way you can use a bar chart is if the variables are categorical in nature. So categorical variables, and as you can see, there are gaps between bars. Why is this second part very important? Further in this unit, we're going to talk about histograms, which look awfully similar to bar charts, but we need a way to distinguish them. So if you look at this, you see data on the y-axis and group on the x-axis. So this has to be a categorical variable. This can be numerical. So if I switched A and B or A and E or any two of these groups around, the bar chart would still make sense. So we're going to talk about dot plots, which is just using dots to represent data. For each dot in this situation or in any dot plot represents a specific value. So what does this mean? So in this case, for this dot plot of number of brothers and sisters, I'm going to let each dot represent one data point. So that means the number of people who have 0 siblings is 1 plus 1, which is 2. The number of people with 1 sibling is 3. The number of people with 2 siblings is 5, and so on. Next would be the height of the column represents the absolute frequency of the category. So what this means is that if in this situation represents 1, it has to represent 1 here and 1 here and 1 here. It can't be that for people who have 0 siblings it represents 1, but for people with 1 sibling it represents 6. Lastly, the type of variable can be either categorical or quantitative, which makes this a very versatile type of graph. Is the histogram, which looks awfully similar to the bar chart. Again, it is using bars to display data. However, there are two key factors you must remember. The variables have to be quantitative in nature. As mentioned above, bar charts have to be categorical variables. And now since it is quantitative, we can talk about skewness. What is skewness? That is something I'll come to later in this unit. But for now, let's examine the histogram. As you can see, there are no gaps between bars, and these all are number ranges. So the x-axis has to be some sort of quantitative variable. So this could be height or weight or number of meters run in however many seconds. Stem plot or stem and leaf diagram, which is using values to represent some sort of frequency. Since we're using values to represent frequency, the variables have to be quantitative. They have to be able to be assigned a value. A lot of students forget this, so I'm going to put it in all caps. Remember the key. Without the key over here, these numbers are meaningless. For example, if I didn't have the key, this could mean 5.6 or 5 times 6 or 5 raised to the 6th. It has no value. So now knowing this key, try this section and write out all the numerical values that you think are represented in the stem leaf diagram. So the way we write the key firstly is your stem part followed by a bar followed by your leaf. So this reads 5, 6 as 56%. Try this out yourself. These values, if you didn't, let's take a look at where these come from. So for example, this 67%, you read it as the stem, which is 6 and then 7. And it gave you the key that it means 67%. Similarly, 94 comes from 9 bar 4, which is 94%. So 67, 69, 72, 74, so on, so on, so on. Talk about the box plot, which is just a standardized way of displaying a distribution. It is also a visual representation that lets us see a lot of data points at once. So if you look at this box plot over here, you see outliers, lower whisker, lower quartile, median, upper quartile, and upper whisker. Now there are 6 things you can notice here, but we count only 5 in our 5-number summary. The first one is our median. The next one is first/lower quartile, generally represented with a capital Q and 1. The next one is third or upper quartile, represented with a capital Q and 3. Your lower bound or whisker, and finally your upper bound or whisker. So we will talk about all of these later except these two, which are fairly self-explanatory. Lower bound or lower whisker just means the lowest point of the data that is not outlier. An outlier is something that is abnormal from the data. Why don't we include outliers in our 5-number summary? Because not all data values or not all data sets have outliers. These will be standard across every single set of data. The chart is just using circular pieces of data or circular pieces to represent data. What we must understand is that it has to be categorical data or categorical variables. So if you look at this pie chart over here, you see calculus, economics, physics, and statistics, which would mean that I can assign an adjective to these. I can't assign a value to statistics. I can't say that statistics is 40 statistics. That doesn't work. Secondly, we must remember the area principle, which just means that each data value must be represented by the same area. So if I had statistics equals 13.8%, if physics was double of statistics, physics must be represented by twice as much area. It can't be half as much, it can't be 1.5 times as much, it has to be double. That is what we call the area principle. Move into the realm of describing data. We're going to start with this, CUS. What does it mean? It just refers to the acronym of center, unusual features, spread, and shape. So when we talk about center, it just means approximate the middle value of the data. When we talk about unusual features, we talk about outliers or gaps. Spread would be your range, and shape would be whether it's left or right skew, whether it's bimodal, which means multiple peaks, unimodal, which is single peak, or symmetrical. So what do I mean by all of this? The center just means what is the tipping point or the balancing point of the data. Unusual features just means something that is abnormal or strays away from the general shape of the data. Spread just means your range, your highest value minus your minimum value. And your shape left skew, right skew, which we will talk about. Symmetrical just means that it's uniform. Unimodal means that it has one peak, like for example this would be unimodal. Bimodal, although counterintuitive because bi refers to two, means multiple peaks. Are there many positions where you find a maximum? If a data isn't symmetric, it is said to be skewed. So in these situations, I have put two pictures to illustrate what I mean. So this would be right or positively skewed. As you can see, the big hump or the peak is on the left side of the data. So this just means that most of your data is clustered around the left side, but there's some small amount of data on the right side. As you can see, the mean is greater than the median. On the other hand, for negative or left skew, the mean is less than median. So it would be in this shape. This is a left skew or negative skew, and this is right or positive. Teachers will interchangeably use positive and right, but it just means the same thing. It's important to know in statistics the different ways of saying the same thing, because they could quiz you or test you on any one of the sayings. Talk about three things that a lot of people have heard of before: mean, median, and mode. So the mean is just the average value of all data points. It is in fact impacted by outliers. So if I had a data set like this, the mean would be some x value, which you should find soon. But if I added a value like 2000, the mean would drastically shift. If I added a value like negative 500, the mean would drastically shift. Pause the video and try to find the mean of these data points yourself. And did you get this answer? So what I did was I added all of these data points together and divided it by the total number of data points. So 1 plus 15 plus 25 plus 30 plus 9 plus 15 plus 19 divided by 7, which is your total number of data points, which gave me this value. Next is the median. So median is just the middle point of all data values. As I mentioned above, when I talked about center, you generally refer to what the median value is. Median is impacted, well, firstly, the data must be in ascending order, which means lowest to highest. It is impacted by the number of data points. The median, if let's say all values were different, if I had the median, or if I had 5 data points, the median would be a lot different than if I had 500 data points. Now, I'd like you to find the median of this data set. Pause and try it for yourself. First, I relisted the entire data set in ascending order, from lowest to highest. Now I found the middle point. Since there was exactly 7 data points, it was easy. I find the 4th data point, which is just 7 plus 1 divided by 2. So now you can see there are 3 points on either side of this. Now, for example, if I added a number for, let's say, 45. 45 is the greatest number, so I'll add it here. Now what is the median? Now we have 8 data points. 8 plus 1 divided by 2 is 4.5. So what you do is, you take the 4th data point and the 5th data point, and you average them. So in this case, your median would be 10 plus 12 divided by 2, which isn't a value you have in your data set, 11. But it is still your median. We're going to talk about mode, which is just the most frequent data value. In this data set, you can find the mode. Pause and try it, or you can just continue listening to me tell you what it is. It's 12, because the occurrence of 12 is 4 times. It's very simple. The range is your difference between the highest and the lowest value. Find the range of this data set, which I can tell you right now is 99 minus negative 10, which is 109. So your range can be positive, it can be negative, it can also be 0 if your highest and lowest values are equivalent. Now we're going to talk about IQR, or interquartile range, which is the difference between your 75th percentile and your 25th percentile, or as I referred to above, Q3 and Q1. What does this give you? This gives you the middle 50% of values. It just gives you the difference between the 75th and the 25th percentile. So what we refer to as the 50th percentile is Q2, or your median. Another thing the IQR is useful for is it's used to calculate outliers. So outliers again are something that's stray from the data. It's abnormal. So what are your high outliers? If your value is greater than your 3rd quartile plus 1.5 times your IQR, we'll say it's a high outlier. if your value is less than your first quartile minus standard deviation are two very key concepts, but they are very simple to explain. They're just numerical values to indicate how widely spread the data set is. The relationship is illustrated as standard deviation is square root variance, or standard deviation squared is variance. Moving on to z-score, which is just a value that allows us to find how far away or how many standard deviations away from the mean our given data is. It is illustrated by this formula, value minus mean divided by standard deviation. Now it can be positive or 0 or negative. Now I want you to try the bottom two questions by yourself. If I get a score of 50 when the class average is 25 with a standard deviation of 5, what is my z-score? If my z-score is negative 1.2, my score is 30 and the class average is 45, what is the class standard deviation? These two questions will show you how to manipulate this value. Here, if my score is 50 when the class average is 25 and a standard deviation of 5, so that's 50 minus 25 over 5, which is 5. So that just means I'm 5 standard deviations above the mean. I'm pretty good, I have to say. If my z-score is negative 1.2, my score is 30 and the class average is 45, what was the class standard deviation? So my score minus class average divided by standard deviation gives me my z-score. Standard deviation of 12.5. Now, if you didn't understand why I said my score of 50 with a class average of 25 and standard deviation of 5 was very good, this will illustrate it. Here's the empirical rule, or sometimes referred to as the 68, 95, 99.7 rule. It just means that 68% of data lies between 1 standard deviation of the mean, 95% of data lies between 2 standard deviations, and 99.7 lies between 3 standard deviations. If your data is within the 68%, you call it usual. You generally expect values to be there. In the 95 bracket, it is unusual, and in the 99.7, very unusual. So in this purple area, we'd say you'd expect a lot of values to be there. In green plus purple, you wouldn't expect it, but it's not that uncommon. In orange plus green plus purple, you would say very unusual. So that's your 97. So the orange parts would be very unusual and the green parts would be unusual. About 6 different things that you could use to describe data: mean, median, mode, standard deviation, IQR, and range. Now I'm going to show you how constants impact the data. So I'm going to give these values first. So for example, for a mode, I'd say 5. And you know what? I'll make all of these 5. For median 5, mean 5. For addition, we'd say plus 6, subtracting minus 6, multiplication times 6, and dividing by 6. So this just means I'm adding 6 to all values, subtracting 6 from all values, multiplying 6 to all values, and dividing 6 from all values. So if I add 6 to all my values, my mode will go from 5 to 5 plus 6 as 11. Subtract would be minus 1. Multiply by 6 is 30. Divide by 6 is 5/6. Similarly, it would happen for all of these things. If you don't believe me, let's try it with some data values. So if I had a data value of 1, 1, 1, 2, 2, 3, my mean would actually be, this is the set, 1, 1, 1, 2, 2, 3, 4. Now, if let's say I added 5 to all of these, added 6 to all of these, right? So I will change that over here. So 6 to everything will give me 7, 7, 7, 9, 9. Oh, sorry, 7, 7, 8, 8, 9, and 10. So that means that's my addition. Now I'll do the subtraction and multiplication and division, and then you just do it as well. Pause and try these values. I'm hoping you did get these values, and now you can see how the impact of constants changed your mean, median, and mode. Some of these I had to simplify so that the formatting would come out right, but this is just your 2/6, your 3/6, and your 4/6. Now for standard deviation, it just means how widely spread your data is. So if I had this, let's say my standard deviation was, let's say 2, for example, my IQR was 2, and my range well, my range is 3. Now again, when I add all these values, so in these cases, my range is still -2 minus -5, which is 3, and over here is 10 minus 7, which is 3. My IQR, let's say my IQR was this value minus this value. So my second last value minus my third value, which is still 2. Again, still 2. My standard deviation was the arbitrary value, so it's still 2. It won't change. But if I multiply it, these values change. So my range becomes now 18. My range is now 3/6. My IQR changed, and everything else changed. So only will multiplication and division change my values of spread. About is norm CDF and inverse norm, or your normal cumulative density function, or inverse norm CDF. So what does it mean by the normal cumulative density function? This function actually returns the probability that a value lies between two data points. So the syntax is given as this: norm CDF, lower bound, upper bound, mean, standard deviation. So it's the probability that my value lies between these two data points. So if I said norm CDF of 0.2, 0.8, 0, 1, this just means that if the probability a value lies between 0.2 and 0.8 given a mean of 1, given a mean of 0 and a standard deviation of 1. This comes out to about 0.3 something something something. The other way of finding this probability is, in a sense, using Z-score. So if you were given the value, so let's say you were given something like 0.6 and you wanted to find how many standard deviations away from the mean it is given these values, you can plug that in. So that's how Z-score relates to norm CDF. It will give you the number of standard deviations above the mean it is. Now, norm function. So this function returns the x value given the area to the left. So what does this mean? So if I have the syntax like this, inverse norm, area to the left means standard deviation. So that means if I said inverse norm of 0.5, 0, 1, or let's say 0.8 to make things easier, 0.8, 0, 1, it'll give me the x value that is the 80th percentile given a mean of 0 and a standard deviation of 1. This isn't that difficult to understand because this just means the percentile. So what value is at the 80th percentile? Now this relates to Z-score even more because we're trying to find the value minus your mean divided by standard deviation that is equivalent to the 80th percentile. 80th percentile is, again, from here you can figure out how many standard deviations above the mean, and that'll make it easier. Thank you so much for watching this video. It was about 20 something minutes. Hope you could bear through it. Till next time.